Hello. So I'll bring this here just real quick. Don't judge me. But so we have kind of not glued anything yet. We drew our own chloroplast. That's where we're going to come back. So we drew our chloroplast. We did the light reactions. We walked through Calvin cycle, but we haven't written anything down here. So that's what we're going to do. And we're going to use what we need to use out of the glue ends. I wanted to show you a website because since we didn't use the glue and we drew our own chloroplast, you don't need that. We did the Calvin cycle ourselves. I'm actually going to glue in this piece, but I'm going to show you a place where you could go to just draw it. And we don't have to do the cyclic figure because we've already included that in the light reactions. So that means that if you don't have these glue ends, you're going to be okay. The only thing you would need is to have this piece. So I'm just going to walk you through, and I'm going to start marking off what we've already done. So we labeled the chloroplast. That's done. Emergent properties, I'm going to circle. If I can get back to it, wonderful. If I can't, whatever. Where the chloroplast's found, that's where we are right now. And so I'm going to tear this page off, and I'm going to use this figure, only because it's quicker. But you can also pause the drawing if you don't have this figure, and you can... Okay, so now I've got my little figure, and I'm just going to add it along here on this page, and I'll label it, because there's not really that much to talk about as far as notes to add for the chloroplast. But we do need to go, and talk about where it's found. Alright, so okay, so I hate doing this because actually the mic is in here. You can't see that I'm pointing to, but it's in the document camera, so every time I move it, it loses its mind. So chloroplasts are inside of mesophyll cells, and that doesn't help a bit if we don't know what it is. So there's a really cool website, and it's this, believe it or not, let's see what it's called. Flying Turtle, I think is what it is. Let's see here. Yep, flyingturtle.org. So I will write that, and you can see it once we come back. What a weird... And they have really good illustrations of what we're doing that line up with ours. So I moved it over into a document, and we know from a leaf section that this is a piece coming from a leaf. I don't feel like that I need it all to put that on there. But we do want to label what is in this leaf. So it looks a whole lot like our figure. And so if we go here, this is going to give us everything we need. So I'm going to pause, and I'm going to add the details on the figure. And then when I come back, I'll talk you through it. So I have added in the detail. The copy's terrible. It's a little better when you look at it this way. So you have a series of very regular shaped, thin layer of cells right here. This would be the top part of the leaf section. And then this is actually the bottom. So this is what you see, and then this is going back into the paper as the underside of this leaf section, because we've cut all the way through. So on the top, very, very, very top, and very, very, very bottom, you have a cuticle. And it's just a waxy coating that protects the whole leaf. You felt it. You know what it feels like from losing water. Right underneath that cuticle on both sides is epidermis. So you have an epidermal cell layer right here, and you have another one right here. The way you can tell the difference between the top and the bottom of the leaf is that on the underside of the leaf, you have these, look like little mouths. That's what stomata means. And so you've got these, what are called guard cells, and they're placed in such a way where that when there's low water in the cell, they kind of deflate, and then you have a change in the way that they're open. And then when they're filled with liquid and they're more firm, then you also have a different way that they open. So that's what these are. So there's 2 guard cells that make up 1 stomata. And when you want to talk about all the stomata, they're called stomates. But they're on the underside of the leaf. So in between the top of the leaf and the bottom of the leaf, you have 2 layers of mesophyll. Meso means middle. So I didn't put that in there. I'm going to put it over here, that you've got this densely packed parenchyma, which is called palisade. So the cells are really tightly stacked together. And then under that, and you've pulled a leaf apart, you've seen this part, you've got parenchyma that's less ordered, and there's more space, there's air space in between. And so all the parenchyma, along with the vascular tissue, makes up the part of the leaf called mesophyll. And here's an example of a mesophyll cell. So this outer part, I think I'll make it orange. Is the cell wall, because plant cells have cellulose as their cell wall. All plants also have inside the cell wall cell membranes. One of the largest features in a plant cell is the vacuole. So that's what this great big thing is here. Most of the time, it's full of water and other kinds of things, but it's meant to be involved in water balance. This larger piece here, which really should be double membrane because it's the nucleus. Then you have, along this perimeter, that's where the chloroplasts are. They're free to move, so you'll see that they'll move in real time. If you're watching them go through photosynthesis, they'll move. And they do that based on light availability, and some of it's protective and some of it's to gain more light. So that helps us get a feel for this cell would be one of these cells in this mesophyll, one of the parenchyma cells. Mostly you're going to have photosynthesis occurring in this palisade layer. The epidermis is pretty see-through for light to come through, and so light would penetrate this way. Coming through the top of the leaf and hit this palisade, and these don't really, this spongy's not nearly as involved. So one of these cells, these right here underneath your epidermal cells, this parenchyma, you're going to have a mesophyll cell, which just means a cell that's found in the middle, and it's going to look like that. And so this particular organelle, this chloroplast, is what we drew up here. And so the only thing I would do differently up here is I would include, let me see if she does this and maybe it'll help us see what we're going to do. I don't know if she does. Let's see. Okay, she does. So here's her chloroplast. Ours looks a whole lot like that. And she's stepped out of the just a simple way of looking at it. And she's made sure that we understand that there is a double outer membrane. And then you've got all of the stackable bilicoids inside. So I think I would add that. So if you notice, we've got to add in this little second so we can visualize. Because this right here, even though it looks double, this is the problem. Is what it is it's a bilayer. So we've got this piece right here. And what I usually do is I just add a couple of phospholipids so I know that's a bilayer. So inside that is another membrane. And so this is going to be, if we do this, where did I put that? Where did I put I did not label it at all? Well, okay. So this part right here, I'm going to just kind of circle it right here. Maybe I'll just shade it. It looks weird. So this is going to be the outer membrane. And I think I'm just going to add bilayers so I don't have any problems with knowing that. And then I'll point to the second one, and it's going to be the inner membrane, so that we recognize that there's a double membrane. And the reason why that I'm stressing that is a double membrane is evidence of being engulfed. So let's maybe go over here and put a little note to ourselves. Why a double membrane? And if you didn't have room here, you could add it down here. So if you were something free living, so we're just going to kind of make something here, and we'll put here that you are a free living, and we've always just stopped at prokaryote. And then you've got some other cell. So this is going to be just some cell that's going to engulf this cell, the smaller. So this is through endocytosis. Eventually what would happen is you'd end up with this free-living prokaryote all the way in. So it would have, maybe I should do that. I think what I'll do is I'll make its membrane red. So it's got that's its original. So red equals its original outer membrane. And when it's engulfed, it would be still have its original, plus this is going to continue around until it completely encircles that. And so then you'd have an outer host membrane, because it would come from here, right? This and this are the same thing. So you now have a double membrane. And this is going to be its evidence of being engulfed. And so what that does is it's going to be support for the endocentric symbiotic theory, which says that the chloroplasts and the mitochondria were originally free-living prokaryotes, and they were engulfed by a larger, probably prokaryote, and then once you had the organelles inside, now you've got your beginnings of a eukaryotic cell, and that's how the eukaryotic cells came into being. So that's what we would add there. So I think that's it for this. We've labeled everything. So I'm going to stop this one, and then we'll go to the light reactions and write our notes under there.